You know, some stories are about people and some are about places. But this is the biography of a single drug that literally changed the world, chloroquine. And let me tell you, it's a story of incredible discovery, of hope, a really dramatic fall from grace, and a pretty stark lesson for all of us today. Think back just a little while ago. The name chloroquine, which, let's be honest, was a pretty obscure anti-malarial drug, was suddenly everywhere. It was on the news, it was in daily press briefings, and it was right at the center of this huge global debate. And that right there is the big question we're going to unpack. How on earth did a drug that was developed before World War II become one of the most talked about and, frankly, controversial substances during a 21st century pandemic? Well, the answer isn't so simple. It's all tied up in the drug's entire crazy history, its amazing rise, its hidden powers, and yeah, its lurking dangers. To really get what happened recently, we've got to go all the way back to the beginning. You see, before it was controversial, chloroquine was a hero. I mean, a genuine world saver that completely changed how we fight one of humanity's oldest and deadliest enemies, malaria. So the story really starts with a natural remedy, the bark from the cinchona tree. But then fast forward to the 1930s, and scientists managed to cook up a new synthetic and way more potent version. After World War II, it was basically unleashed on the world, and for decades, it was hailed as an absolute miracle drug in the fight against malaria. And it became a global staple for three really simple reasons. It worked unbelievably well, it was super cheap to make, and at the time, it was considered pretty safe. This thing was the perfect weapon, a cornerstone of public health that saved, well, an untold number of lives. Millions, for sure. Okay, but here's where it gets really fascinating. Its success and its eventual controversy, it all comes down to the science of how it works. And the amazing thing is that this one little drug is basically a master of multitasking inside our bodies. So what's its secret? Well, it's kind of like a double agent. It has one very specific job when it's fighting an invader, like malaria, and a totally different job when it's dealing with our own immune system. So let's start with its first and most famous job, being an assassin. Its main mission is to kill the malaria parasite, and it does this through a brilliant little act of biological sabotage right inside our own red blood cells. Okay, so check out how clever this is. The parasite gets inside our red blood cells and starts eating our hemoglobin, but this creates a toxic waste product called heme. Now, the parasite has a defense. It usually turns that toxic heme into harmless little crystals. But chloroquine sneaks in and blocks that process. The result? The parasite basically gets poisoned by its own garbage. It's an incredibly smart mechanism. So you have these two totally distinct roles. On one hand, it's an assassin poisoning the malaria parasite with its own waste. But on the other hand, for autoimmune diseases like lupus, it's more like a diplomat. It goes into our immune cells, raises the pH just a bit, and that messes with their ability to sound the alarm. It basically turns down the volume on our body's own attack systems. Two jobs, one molecule. But you know, no hero's story is ever that simple. After decades of being the undisputed champ, chloroquine's biggest enemy started to adapt. The parasite itself began to evolve. And this was the huge turning point. The malaria parasite developed a mutation that created this tiny molecular pump, and what this pump did was amazing. It could recognize chloroquine, grab it, and just spit it right back out of the cell before it had time to do its dirty work. Just like that, in many parts of the world, the miracle drug was useless. And the problems didn't just stop with resistance. We also started to get a much clearer picture of the drug's dark side, the inherent risks and side effects that come along with it, especially when you use it for a long time. Now, a lot of the side effects are kind of what you might expect. You know, nausea, headaches, rashes, annoying for sure, but usually not life-threatening. But that is definitely not the whole story. The biggest risk, the most significant long-term danger, is to the eyes. With prolonged use, chloroquine can cause irreversible damage to the retina, and that can lead to permanent vision loss. It's why any patient on it long-term has to be monitored constantly. And the risk isn't just a long-term thing. An overdose is a massive medical emergency. The line between a dose that helps you and a dose that can kill you is frighteningly thin. So, what we've got is a drug that was a hero, then got defeated by evolution, and also happens to carry some really serious risks. All of that adds up to a very, very complicated legacy. So where does it stand right now? Well, for the deadliest type of malaria, it's pretty much obsolete because of resistance. But it is still used for some other types of malaria. And crucially, for those autoimmune diseases, it's still a key treatment, relying on that second, immune-calming superpower it has. And this is what brings us full circle. When you know this whole complex backstory, that it fights parasites and modulates the immune system, you can start to see why, in the absolute panic of a brand new pandemic, scientists thought, hey, maybe this old drug could work. So what was the final verdict on COVID? Well, the initial hope came from lab studies, what we call in vitro data. But hope isn't the same as evidence. Once they ran large, high-quality human trials, the answer was crystal clear. Chloroquine gave absolutely no benefit against COVID-19. And, what's worse, it actually came with an increased risk of serious side effects, including very dangerous heart problems. The whole episode became this massive, real-world lesson in a fundamental truth of medicine. What works in a test tube doesn't always work in a person. The human body is just way too complex. It showed us that rigorous clinical trials aren't just an option, they're everything. So, in the end, what is chloroquine? It's a fallen hero in the war against malaria, it's a continued helper for people with autoimmune disorders, and it's a powerful, powerful reminder about the importance of scientific evidence. When you really think about it, the biography of this one drug is actually a story about us. It's a story about our incredible ingenuity, but it's set against the humbling, relentless power of nature to adapt and fight back. It really just reveals this endless race between human science and natural evolution.